Welcome to your Finite Math Lesson 1.2, Day 2. We're going to continue talking about modeling real-world situations with linear functions. In particular, we're going to do cost analysis. The cost of manufacturing an item commonly consists of two parts, the fixed cost and the cost per item. Fixed cost is simply that, the amount of money needed for operating expenses regardless of how many items are manufactured. So if you produce one item or you produce 1,000, you're still going to have the same fixed cost no matter what. So these include costs for designing a product, costs for setting up a factory, training workers, overhead, rent, employee salaries, office products, etc. The cost per item are the materials used to manufacture the product, packing, shipping, advertising, etc. The cost here depends on how many items are actually manufactured. Suppose that the cost of producing a certain type of book can be approximated by C of x equals 12x plus 100. Okay, so the 12 here is the cost per item and the 100 is the fixed cost, just so that you know. What is the cost of manufacturing 15 books, 81 books? So this is two different scenarios. We're going to find the cost for producing 15 by plugging 15 in for x. Remember in function notation on the left here when we write C of 15, that just means we're finding the cost when x equals 15. That is all this means. It's not like a mathematical operation or anything. It's just keeping track of what we've plugged in for x. So that's going to equal 12 times 15 plus 100, which turns out to be 280. And the reason function notation is nice is because we can look at it and go, okay, the cost for 15 books is $280. So let's do C of 81. So that would be 12 times 81 plus 100, which is 1,072. So the cost for 81 books is $1,072. Marginal cost is the rate of change of C of x. The cost function, it is the slope, it's the cost per item. In a cost function in the form C of x equals mx plus b, m represents the marginal cost per item, so how much it costs for each additional unit to be produced, and that is an economics term, and b represents the fixed cost. The marginal cost to make X tablets of a prescription medication is $10 per batch, while the cost to produce 100 batches is $1,500. Find the cost function given that it's linear. All right, so we know we have a linear function, and we can define that function if we're given the slope and the y-intercept, the slope and a point, or the slope and 2 points. So let's look at what we're given. The 100, 1,500 is actually an ordered pair, where x is the number of tablets, so that would be the 100, and then y is the actual cost, so that would be 1,500. So we have a specific x, a specific y, so in terms of our equations for lines, we have an x1 and a y1. We're also told the marginal cost, and that's the slope. That is m, and so it's equal to 10. So we have everything we need to plug into point slope form, and we will work with it then to put it in the C of x equals mx plus b form. Now, we're not going to use C of x to the very end. We're going to use y just because that's just easier to work with. So point slope form is y minus y1 equals m times x minus x1. Now, why are we starting with point slope form? That's right, because we've got a point in the slope. So the information we have tells us exactly which form to start with. So we've got y minus 1,500 equals 10 times x minus 100. So we did y minus our y1 equals m times x minus our x1. So y minus 1,500 equals 10x minus 1,000. And so we're going to add 1,500 to both sides, and we get y equals 10x plus 500. Now we want to go ahead and put it in the form C of x equals mx plus b. So instead of y, our final answer will have C of x equals 10x plus 500. So from this, we can affirm that the marginal cost is $10 per batch. And then here, the plus 500, that's telling us that the fixed cost is 500. All right, related with cost is revenue and then profit. And a lot of times where companies are interested in their break-even analysis. Okay. The revenue function R of x from selling x units of a product is the product of the price per unit P and the number of units sold, which is the demand. So R of x equals P times x, where P is the price per unit and x is the number of items sold. Okay, so that's the money brought in. That's not actually how much money you clear, how much money you make your profit. Your revenue is just how much money you bring in. You have to subtract off the cost, the amount of money you spent, in order to make the products to get your profit. So your profit function is the amount of money accumulated by selling X number of items minus the cost of producing these items. So P of X, big P of X, that's not the same as little p times X. Little p is price, big P is profit. P of X equals R of X, the amount of money you bring in, minus C of X, the amount of money you put out in the first place. So profit equals revenue function minus cost function. Now, the break-even point is the point at which the cost of manufacturing X items equals the amount of revenue made when these X items are sold. It's where your profit is exactly zero. You've made up your investment. After that, you start accumulating a profit, and that's when things get really good if you're in business. So your break-even point is going to be when R of X equals C of X, and the value X is the quantity that you need to sell to have reached your break-even point. Okay, so producing X units of tacos, I don't know if that's dozens or, a gross of tacos, 100 tacos, but whatever. Producing X units of tacos cost C of X equals 5 times X plus 20, and the amount of revenue is 15 times X, where C of X and R of X both represent the amount of money in dollars. So what is the break-even quantity? Well, that's going to be where your revenue equals your cost. So where R of X equals C of X. So let's just plug in what we have. That's where 15X, because that's R of X, equals 5X plus 20. Okay, so they're going to have to give you this for every situation. R of X equals C of X is going to be true no matter what situation you're in. That's how you find the break-even quantity. You plug in the specific functions for R of X and C of X, and that will help you solve that for the particular situation you're studying. So we subtract 5x from both sides, we get 10x equals 20. So if we've got 10 times x, to undo the times them by 10, we divide both sides by 10 and we get x equals 2. The break-even quantity is 2 units of tacos. So once somebody sells 2 units of tacos, that's when their revenue equals their cost. After that, they'll be making profit. Before that, they're losing money. So if this is going to be a viable business, they need to always sell 2 or more tacos. Okay, what's the profit from 100 units? That's good to know. Remember, profit is equal to revenue minus cost. So in particular, the profit from 100 units is going to equal the revenue from 100 units minus the cost of 100 units. So let's find those two values separately. The revenue of 100 is equal to 15 times 100, because our X value is 100, which is 1,500. The cost for producing 100 units of tacos is equal to 5 times 100, because 100 is our X value, plus 20, and so that's 1,020. So our profit from producing 100 units of tacos is going to equal 1,500 minus 1,020, our revenue minus our cost, and so that's $480. So the profit from selling 100 units is $480. How many units will produce a profit of $500? Okay, sometimes people want to know that. I need $500. How many units of tacos do I need to sell? So the $500 is our P of X. So we're still using P of X equals R of X minus C of X. So we're going to plug in 500 for P of X. R of X equals 15X. And then we're going to subtract all of the expression for C of X. So minus and then parentheses 5X plus 20. That's very important. Then we're going to distribute the minus sign. So we get 500 equals 15X minus 5X minus 20. Combined terms, we get 500 equals 10x minus 20. Add 20 to both sides to get 520 equals 10x. Divide by 10 and you get 52. So it will take 52 units to produce a profit of $500. Okay, you're going to use your graphing calculator to verify the break-even quantity found in Part A. So go to the graphing scratch pad like we did with supply and demand and finding the equilibrium point. We're going to let f1 of x equal 15x and f2 of x equal 5x plus 20. So we're putting r of x in one function and c of x in the other. Now remember, if you go to your graphing scratch pad and you don't see f1 of x equals or f2 of x equals, if you press tab, you'll be able to do that. Okay, so the graph with the standard viewing window looks like this little picture here. The break-even quantity will be the x value where the two functions intersect. Remember, it's where r of x equals c of x, so that's where they intersect. The two functions are getting closer together at the top of the screen, so let's increase y max. So select Menu, Windows, Settings. I set y min to -10 just to make it a prettier number. You don't have to, but I did. And y max to 40. And here's the picture I got. Yay, I can see the intersection. So to find the point of intersection, I need to select Menu, Analyze Intersection, and then select a place to the left of the intersection point when you are asked for the lower bound. And then you'll be prompted for the upper bound. Just arrow over to the right or use your, scroll over to the right and then select a point to the right for the upper bound. That gives the calculator a lower x value and an upper x value to look for this little point of intersection. And then boom, it's going to give you the coordinates 2, 30. So this 2 is what we're looking for. The break-even quantity is 2 units of tacos, which is what we found. The 30 is what the revenue is and what the cost is. So revenue is 30, cost is 30, which means profit is 0. So anything after 2 units means they're going to be making money. Anything less than 2 units, they're losing money. 2 units is the break-even point. Okay, guys, you have a problem to try on your own. Go ahead and do that. If you can't do it, either rewatch part of the video or come in and see me, but you need to have that done when you get to class. Thank you so much for taking great notes as always, and I hope you have a great day, and I will see you in class.